Hello friends, welcome to Truth of Physics. In this video, I will discuss on the second thermodynamic potential that is called the Gibbs free energy. Previously, I have made a video on what is thermodynamic potential and also discuss and derive the expression of the first thermodynamic potential that is called our Helmholtz free energy. So the link of the video I will give in the description box. From there you can watch that. So Gibbs free energy. So consider a process that is an isothermal and isobaric process. So in that process, isothermal and isobaric. So in that class, in the derivation of our Helmholtz free energy, we have taken a process that is isothermal and isobaric process. That means there V was constant, and here isobaric means P is constant. Now the work done dW in an isobaric process can be written P constant, P into V2 minus V1, or V final minus V initial. Now dW is equals to or less than equals to F1 minus F2. Right, F is what? Helmholtz free energy. Now F is what? U minus Ts. So I can write this is equals to less than equals to F1 minus F2 means U minus Ts means Ui minus Tsi minus F2 Uf minus Tsf. Now I can write that from here, rearranging, I can take all the I, that is initial states, to right hand side. Then what happens? Then this will be Ui minus Ts, which is basically our, this is our Helmholtz free energy, plus PVi, which is less than equals to Uf minus Tsf plus PVF. So I can, if I denote this thing with another function gf, so I can write gf is less than equals to gi. Now what is this? This G is our Gibbs free energy. That means Gibbs free energy is that thermodynamic potential, or I can say Gibbs free energy is a thermodynamic potential of a isothermal isobaric process, that is at constant pressure and at constant temperature. So this is called our Gibbs free energy. Now similarly, like our Helmholtz free energy, you can understand from here that the final for this process from I to F, for a state from I to F in this process, the Gibbs free energy in the final process, in the final state cannot exceed the Gibbs free energy of the initial state, right? The Gibbs free energy of the final state is always less than the Gibbs free energy of the initial state. That means whatever may be the process, or the process can be any type, but in that process always the Gibbs free energy is tending to go to the lowest. It is meant by that the Gibbs free energy always tending to go to the, if here is our Gibbs free energy of the initial states, suppose this is a diagram of Gibbs free energy, then in that process, suppose A, this is A and this is B. So the Gibbs free energy in this process, suppose in this process, always the final the Gibbs free energy in the final state will always tend to go lower. That is, this means this is, as this is going to the lower, that means this is the stable state. That means the Gibbs free energy, the minimum, the system always tending to go to the minimum of the Gibbs free energy, right? Like the thing that we have discussed in our classical mechanics, the energy in our energy diagram, always the stable equilibrium point is the minimum of the potential energy curve. So here also the minimum potential energy, the minimum Gibbs free energy is the most stable. Remember, this is only for constant temperature and constant pressure. So this is our Gibbs free energy. So I think that you have understand the concepts. Okay, now this thing G is equals to U minus Ts plus Pv. From here you can do many mathematical problems. How? Take the derivative dg is equals to du minus everything will be derivative, then du is equals to what? Tds minus pdv. I can write tds, that is dq, is equals to du plus dw or pdv, right, from first law of thermodynamics. So du can be written like tds minus pdv. Now d of ts means tds minus sdt plus pdv plus vdp. So this will be what? pdv will be cancelled out, tds will be cancelled out, this will left with vdp minus sdt. So dz is equals to vdp minus sdt. From here you can also find a v is equals to del g del p, T constant, or you can find also the entropy S is equals to del G del P, del G del T, del G del T, P constant with a minus sign. So, and from here you can answer the question that there can be various questions in which you have to use this thing, you have to use this relation and then derivative it and then all the things, like in phase transition, right? Phase transition you have to find the entropy, that entropy is discontinuous or continuous, you have to find, then you have to find the expression, the derivatives, that the entropy as in terms of the derivative of g. So in that cases, or there are many various problems involving this thing. So I think that you have enjoyed this video, then subscribe this channel and hit the bell icon to get the notifications of my upcoming videos, and share this video with your friends and take care of yourself. Thanks for watching.